this rate of change of the function in the direction L, which we have found as df over dt taken at t, also has another name. It is called directional derivative in the direction L, and this is another notation using around d taken at x0 point. So once again, this is a sum where coordinates of the gradient vector are multiplied by the corresponding coordinates of the direction L. The only problem is that when we write down parametric equation, the straight line, we use L as the direction vector. But when we change this vector by multiplying it by a factor, for example, we can, instead of L, use double L vector, nothing changes with a straight line. We have the same straight line. Simply a directional vector has a double length compared with the earlier L. But this multiplication by a factor changes the directional derivative. So in order to avoid this ambiguity connected with any length of the directional vector, let's consider, and it will be used further, only a unit vector as the directional vector L. So once again, we'll agree that when we use this formula for directional derivative, the length of the directional vector is always 1. So this is a unit vector. If we continue to write it down as an inner product, we have grad, we have L, and we can recall that the inner product of two vectors can be rewritten as the product of the norms or lengths don't forget, from now on the length of L vector is 1, and the product of the lengths or norms is multiplied by the cosine phi, which is phi, an angle between two vectors. Now, what if we are able to change the direction or the straight line which passes through the x0 point? Each time there is some angle between the gradient. So phi is an angle between the gradient and the directional vector L. So if phi equals 0, the cosine function takes the greatest value and it equals 1. That gives us the result about the gradient vector. Gradient vector points in the direction of the most rapid growth of the function f. So this is the fundamental fact about the gradient. How can we use this fact that the gradient vector points at the direction of the maximum growth or the most rapid growth of the function? Let's consider a production function q and for a particular case we'll consider a Cobb-Douglas function, some particular case. So let it be L cubed times, which is labor, times capital K squared. And there are particular values of labor and capital employed in the technological process. So let L be 1 and K equals 1. Now we are trying to increase the output of the production by employing extra amounts of labor and capital. So the question is, what proportion of additional units of labor and capital we have to use in order to increase the output of the production in the most fastest way. Let me draw the coordinate plane where the horizontal axis is a labor axis and the vertical axis is a capital. Now we're drawing the isoquant. Remember, isoquant is the curve, the points of which provide the same amount of output. So whenever you choose a point from the isoquant, you substitute this bundle of factors into the production function and you get the same amount of the output. For instance, here we have a point where labor is 1 and capital is 1 and the production equals 1. Now, we need to calculate the gradient vector at this point. The gradient vector at point 1, 1. Firstly, how to find it? We can do it mentally. We need to differentiate the function with respect to L and substitute the given values of L and K. Then we have 3. If we differentiate with respect to capital K and substitute the values, we have 2. So this is our gradient vector. And it looks like that. Something like that. Although it's more resemble a vector which points at 45 degrees, this vector clearly has some other angle. But anyway, so we know the gradient shows the direction of the most rapid growth of the production function. So when we would like to increase the production in the fastest way possible, we need to employ additional units of labor and capital, and the arrow which points in the direction of the maximum growth is the hypotenuse of the right angle, whose legs are 3 and 2. So the proportion of the factors we need to employ, additional units of factors, will be delta L over delta K equals 3 over 2. So that's the advice for a firm to follow.